So today we are going to discuss about the big data and Hadoop. So before coming to big data and Hadoop, these two terms, we talk about data because in Hadoop, whatever we are discussing, it's all about data. So means we are doing the analysis, we are doing some summarization. So this type of analytics, we are just predictions on the data only. So first understand what is data. So data, as we know, it's collection of information known as data. But as per the Microsoft, he told like that data is a currency. In what term he said? He said like he makes money from the data. How they are getting the data from different sources, and they are doing some predictions on that data, some analyzations of on some day on that data, and they are making money from that. And as per the Google, he told like that data is everything. It means whatever we are talking to you guys, it's also a data. So they also makes money. Google also makes money from this data only, doing some analysis and making money also. So now coming to data. So as we know, in globe, the data stored in SQL around 20%. Rest of the data, rest of 80% of data is stored as no SQL, means it is not a RDBMS. It means it's stored as a files. So before coming to big data and Hadoop, before coming to the Hadoop framework, we are able to do analysis and we are able to do predictions on 20% of data instead of 80% of data. We can't able to analyze that data. So this is the way in Globe before coming to the Hadoop. So this is the way the data is stored in that. So no SQL means it's not means it is not in the RDBMS. So what is, let's understand what SQL. SQL, as you know, RDBMS concepts. RDBMS, relational database management system. So any tools we can say an RDBMS like Oracle, MySQL, Teradata, DB2. So these are the many more my RDBMS tools are there. So we can able to store the structured kind of data. Here we can able to store only structured kinds of data. Structured kind of data understands like in which has rows and columns means tabular tabular data, which means in the form of tables only. Which whatever the data in the form of tables, that is known as tabular data. It has the rows and columns for identifications, for fetching the for accessing the data. Now coming to NoSQL, it means it is not in RDBMS, not in RDBMS. Which means if it is not in RDBMS, so where that data, 80% of data is stored, so that is stored in files. So any kind of files, not like it is a flat file or it is a text file. So like that, different files are there. So now coming to okay, so these are all about data we have discussed, and we have discussed about how the data is stored in the globe. So now coming to like I have initially when I have MBs of data, MBs means megabyte of data. So we can able to store that data into the Excel. So it's still we are using the Excel, but it's only meant for MBs of data. It can store up to megabytes of data. So for storage purpose and for processing purpose, if I have the data around, take an example, 100 MB, 100 MB of data I have, we can easily store these size of data into the Excel, and with the help of Excel we can able to process like any languages, like VB.NET also support here. So we'll see about the processing. First we are talking about the storage wise only. So we can able to storage here, and we can able to processing and do analytics here also with the help of Excel. But nowadays we know everyday data is growing. Every day data is growing and growing, so MBs of data, which is megabyte of data, becomes 2 gigabytes. So what happened, that Excel is not capable to store that huge amount of data, that is GBs of data. So that's what one of the tools that is known as RDBMS, that is Relational Database Management System, came into picture. That so for storage purpose, RDBMS tools stands for meant for storage only, not for processing. Remember this point. So for storage purpose, we are using MySQL, SQL Server, DB2, Teradata, Netezza, etc. Many tools are there in the market. We can use for the RDBMS tools. But what happened? Like I can able to store that GBs of data into these RDBMS tools, but how we can process this data, because whatever data we have stored, I have to process that data as well. So with the help of any languages, it can support Java, it can support .NET, C Sharp, C++, Python. So these kinds of languages I have to use with the help of API. API stands for Application Program Interface. It provides the, I like take an example. I have a web page, or like you're working on any e-commerce site. So what happened? That page in the backend somewhere the data is stored. So take an example, the data is stored in MySQL or Teradata. Take an example, the data is stored in Teradata. So whatever the like, I'm just accessing some kinds of cooler information or some kinds of utensils related informations on the e-commerce site, so, or Amazon, we get an example. So in the back end, that whatever the pattern I am giving in the Amazon.com, that can fetch from the packet from these tools only, and it will show the result on the web pages. So it means the connectivity happen between these storage and processing. So with the help of any language that provides API, application program interface, or connectivity connection between these applications and storage, that is known as RDBMS tools, where we are getting the data. So this is okay. So I can able to store up to GBs of data into the RDBMS tools, but as I told you earlier, data is growing. So after GBs of data, it becomes TBs of data, terabyte of data. So RDBMS is not capable to store that huge amount of data, TBs of data. So what happened? That's why data warehouse tools, one of the tools known as data warehouse tools, came into picture to store these TBs of data. So what happened here? What is first, let's understand what is data warehouse. So every like data warehouse is like we are buying a huge volume of hardware first, and then on that huge volume of hardware we are just dump we are just installing, we can say dump or install one of the rdbms tools, either MySQL, either SQL Server, either Teradata, or anything on that huge amount of huge volume of hardware. Now it becomes his data warehouse. So like take an example, if I said I have a bucket, and bucket is a RDBMS tools, bucket can store up to 20 liters of water. But my capacity is every day I'm getting 20 liters of water, so I need to buy one bucket every day. Okay. Every day I'm getting 20 liters of water. For storing that water, I have only one bucket. So every day I have to buy one bucket. So what happened, it's a cost, it's a very expensive, because company will not every day they will not buy again and again one tools. Okay, so like that, instead of using bucket, I can go ahead with the drum. What happened, if drum has a more capacity, right? In terms of hardware, we can say if I have GBs of capacity in the hardware, I can go ahead of GBs of capacity. So like that we can use drum. So what happened if you use drum? So every day I'm getting 20 liters of water. So it contains up to, we can say, 500 liters of water. Take an example. So what happened? So around 250 days I cannot buy any bucket. I cannot buy anything. Around 250 days it can easily store like that water there. So like that also here data warehouse is like that only. So instead of going for RDBMS, we have to go for buying a bigger hardware and dump any RDBMS tools. So what happened? It will store up to TBs of data. So as you know, the data warehouse is mainly meant for the historical data. It can store only historical data. So and we can able to store the huge volume of data into data warehouse up to TBs of data. For processing purpose for data from data warehouse, we are using some BI tools. BI stands for business intelligence. Business intelligence. BI stands for one of the tools known as, you can either use SAP BI, OBI, MSBI. So we are not worrying about these kind of tools. I'm just giving an overview about these tools, what is happening uh, behind, like before coming to the Hadoop came into picture, what is happening in the real-time scenario. So understood. So and it is known as OLAP system. OLAP stands for online analytical processing. So what is that? We will explain what is OLAP and what is OLTP. So we'll let you know before coming to this. So as we are aware, we have talked about data warehouse. So data warehouse is kind of bigger hardware where we are dumping one of the RDBMS tools, and it is storing. It is capable for showing the historical data only. So I am telling you one example. Take an and I'll take an example for Amazon.com. So what happened in Amazon.com? Every day, millions of users go for the Amazon.com for buying some products from there. So what happened? They are using the OLTP system. It means online transactional processing system. So that is known as day-to-day data. OLTP stands for online transactional. It is also known as day-to-day data. What data every day is generating, that is stored into the RDBMS tools only, because RDBMS is meant for OLTP system, not for OLAP. So what is that? They are, it's like I am a user, I am a client, you are a client, and you go for the Amazon.com and try to search some utensils or some cooler or some TV, like that. Every user has other different requirements. As per his requirement, he just search, give the patterns. So in the backend, they search and they come back to the home page and give the results to me. Like I'm searching for utensils, they give the utensils pages to me, and I can either search and go ahead and buy the product. So what happened? So if I go for buying that product, they need some information from my end. They need some information like my email ID, my delivery address, my contact numbers, like the information they need. So they can, whatever the information I have given, they store somewhere in the backend. So that's why they store in RDBMS tools. I told you, because it is a OLTP system. Remember this point, RDBMS is a OLTP system, not OLAP, the online transactional processing system, because it is a day-to-day data. So what happened if because RDBMS contains up to GBs of data, up to GBs of data. So in a day or 2 days, that GBs, because millions of users come for the Amazon.com. So whatever the information they stored in the RDBMS, one day it will be full, right? One day it will be, it has no capacity, it will be full. So what will happen? So they can, so what they are doing, so they just copy this data. Either they just delete the data, whole data from RDBMS, and they again go ahead with new data. So it is not like that. So what they are doing, they just move the data from RDBMS tools to data warehouse. Why? Because they at least they store for last 1 or 2 months data for the user at least, so they cannot use store the data from last 1 years of data, because why they are using the they're showing the data from last 1 month or 2 months for the analytical purpose, because like Amazon just want to analytics some of the product, like last 1 month which product has been sold more and more, I just want to analyze it. So from where they can go ahead, because all the data has been stored, they have it stored in data warehouse, and they are using either MSBI or BI and SAP BI tools for that processing of data as per his requirement, and they can achieve the result. Okay, this is the product which has been sold more and more like that. What is the number of count? On which date they have been sold more? On which date they have given the offer? So like that, because they cannot that huge amount of data, they cannot go ahead line by line and see it, because so this is the way they are doing in real time processing analytics purpose. So it we till we have talked with the help of example and all, so it's a kind of limited data. See, data warehouse as it also limited data like TVs. It if the TV's data becomes into PBs, petabyte of data. So what happened? Data warehouse is also not capable to store that huge amount of data. So till we have talked about the limited data. Limited means it has some limitations is there for that data. So what happen if I am getting every day PBs of data, petabyte? PBs means petabyte. Okay. YB means YB, that is a gigabyte, and ZB means zettabyte. So this kind of data every day I'm telling example zettabyte. So what happened? Like as take an example, Google generates 400 plus petabytes per month. He is generating 400 petabytes. It's a survey around last 1 year. I'm not sure about the today survey, this year survey. Its survey go ahead with last year. So I could see it's already generated 400 petabytes of data per month. If we talk about Facebook, Facebook also generate 10 plus petabyte per day. Per day, if we go ahead with 1 month, around 300 plus petabytes generating data per month. So these huge amount of data they are generating in a month. So where we are capable to store, because data warehouse has no much more capacity for storing that data. So where we can able to store. So this huge volume of data like 400 plus petabyte, 300 plus petabyte. This huge volume of data is known as big data. This this huge volume of data, 400 petabyte, 300 petabyte, is known as big data. It means that data which we are not capable to store in our traditional system, which is our existing system, that is known as big data. If you break these two terms, big means huge. Okay, or big means huge. Data means data, huge volume of data where we are not capable to store in our traditional system known as big data. Okay, I got the big data. I have big data. So what is the solution for that? That's what Hadoop came into picture. Hadoop came into picture. So let me write somewhere. I will write here big data. You have to say huge volume of data where we are not able to store in traditional system. Traditional means we can say existing system, existing system. Okay, nowadays in the market, whatever the tools we have, we cannot able to store that huge volume of data into that system. That is known as traditional system. Okay, so that's why Hadoop came into picture. What is Hadoop? Let me explain something right here. Hadoop is a open source framework which is meant for storage and processing of huge data sets, okay, of huge data sets, because if we have huge data, then we go ahead with Hadoop. If we have very small data and we have not that much data, so we can able to store in that traditional system, right? And we can able to process earlier. So Hadoop came into picture for huge data sets. If we are not able to store in our traditional system, that's why Hadoop came into picture. It is meant for storage and it is meant for processing as well. So in one framework, we are getting two tools, that is storage and processing both. So this is the kind of first framework in the market where it has both things, storage and processing. Now coming back in the down, so yeah, so here for the storage and processing, it has, as we have discussed earlier. So for the storage, the concept, one of the tools known as HDFS. HDFS stands for Hadoop Distributed File System. Okay, so SDFS stands for Hadoop Distributed File System, and one of the processing tools known as MapReduce, which is processing tools which has completely written in Java. If you go ahead to create any Java MapReduce application, okay, so you have to write on Java. Why Java? Because Hadoop, whatever the framework, it is totally developed on Java language only. So that's why as per the performance, if you use Java, it will give a better performance. If I say you whatever the tools I have that has been developed in that language, if I use that language only as compared to other language, it has given the better performance. Like take an example, Hadoop written in Java, I use Java for the application program, so it gives a better performance as compared to other language. It is not like that it will not support the other language. It supports the C, C++, Python, everything. But if you use Java, it will be better. But we are not worrying about the MapReduce. We should know what is MapReduce. That's it. Because no companies right now they are using the MapReduce here. Okay. So now coming to okay.
I have one question, brother. Can you pause the video recording?
Okay, so now this is the solution for big data, but let me explain you what is the challenges of big data. Suppose I have the challenges of one challenge I have seen for the storage wise, one challenges. Okay, so challenges of big data has first is the storage and second one is processing. As we have discussed, because we have a huge volume of data, we cannot able to store that huge volume of data into our traditional system. So first challenges we have with big data is storage. And after suppose anyhow we can store that data in somewhere, like I can able to store somewhere, not a problem. But what about the processing? How you can process that data? So that is other challenges. In storage, there are two topics come into picture. That's one is the volume. Volume is known as size. Like I am talking about if I say I have 200 PBs of data, that is a petabyte of data. Okay, so that is a size of the data. That is volume of data. And now coming to varieties. Varieties means different varieties I have. Like data has also different varieties. So what is the varieties of different data here? Okay, so what is the different varieties of data here? So first is structured and semi-structured and unstructured. There are three kinds of data. So let me talk about structured kind of data. So I'm telling like a tabular data, tabular data. So like tables in the RDBMS, that is the structured data. Now coming to semi-structured kind of data, we can see logs, we can say XML file that is in the tags format. We can say JSON file that is a key comma value pair. So this is the way, this is the semi-structured kind of data. And we have already discussed about the unstructured like images, audio, etc. So this is the unstructured kind of data. So these are the varieties we are saying. If we have tabular data is a structure, so we can easily process this tabular data with the help of RDBMS tool. That is not a problem. Semi-structured data, if you have RDBMS tools not support the semi-structured like logs, XML, JSON file, etc., and also not supported the unstructured kind of data. So that's why Hadoop came here, and it supports the all varieties of data. It can able to store structured, it can able to store semi-structured, it can able to store the unstructured data as well. So now coming to processing. So what is happening in the processing here? So first is the velocity. I explained, like I am getting, like I have a bucket and drum. I have taken the example in the data warehouse. So what is happening here? Every day I am getting 20 liters of water. Every day I'm getting of 20 liters of water. So that is my velocity. That's my velocity. So I am like I'm just taking an example here for the velocity. If I have, if I am getting 10 petabyte of data per day, I'm getting 10 petabyte of data per day. This is my velocity here. I'm getting this, the data by this speed here. The velocity means speed. I'm getting this data. So take an example. If I have 10 petabyte of data per day I'm getting, and my capacity of the data warehouse or any tools has, take an example, 100 petabyte. Okay, so in 10 days it will be full, right? Next day I'm getting 10, next day I'm getting 10. If you sum up this 10, 10, 10, so in 10 days it will be full. So that's what it is also challenges there. So in Hadoop, so this also avoids. So he told like that, okay, whatever the speeds of data, whatever the data is coming into our system, how much speed, I can able to handle that data. If you are sending the data around 50 petabytes per day, I can able to store that data in our cluster. So we'll talk later what is cluster and all these things. Now coming to veracity. Veracity stands for data scrubbing and data cleaning. So what is that? Like take an example. I'm getting data from different sources here, like from uh, internet, from YouTube, from Facebook, like that. Many sources are there from where we are getting data. So you mean like all the data is the meaningful data? Meaningful data in means of all the data is a valuable data where before where I can go ahead with analysis after getting the data. No, because that data is coming from the internet, and internet, if you are getting data, it may be like somewhat the data is null, somewhat the data is dummy data in the file. So it's like that. It happens every time. Like so, we are get downloading some files. So after downloading, some of the files also junk files also created there. So it has also some of the in dummy data is there. So it's like that from the internet it happens. So before processing the data, after getting the data, we have to clean it or scrub it. It means we have to clear the data, whatever the junk data, whatever the not meaningful data is there. So first we have to clean that, then go ahead with process or means analyze that data. So that is the main procedure for getting going for the analytics purpose. First you have to get the data from different sources, then go ahead and clean the data, then go ahead with process the data. So this is the main procedure we can say, or process we can say. Okay, so these are all about the challenges. So these all challenges has been avoided by the Hadoop framework only. So now coming to the, okay, so till we have discussed about Hadoop. So like every product has its own vendor or its own developer. Developer in terms of companies should be there. That is a third party. We can say if I am using Microsoft Office, I am using the vendor of this Microsoft Office is a Microsoft. If I'm using at my organization level, so organization has to pay to Microsoft for using a Office software. So like that, Hadoop has its own vendor like Apache. Apache is one of the vendor who developed this Hadoop framework. If you use Apache framework, you have to pay to that company, Apache vendor only. That is a third party. We can say these are third party applications. This is not our application. So like that, Cloudera also. If you are using Cloudera distributor, so you have to pay that. Hortonworks and Mappa. So there are many more vendors are there that for this Hadoop framework. You can use either anyone. So till we have seen about the Apache distributor. Okay, Bilal. So now coming from today class, I will go ahead with Cloudera. We will start the work on Cloudera. So it's similar things. There is no difference with Cloudera and Apache and Hortonworks and Mappa. Only the difference is the somewhat the UI is different somewhat, and somewhat the console is also okay. Everything is okay. For Hortonworks is totally different. Okay, as I know, because there we are using the Ambari, one of the GUI is there, so it's different as compared to Cloudera and Apache. But most of the real-time scenario in the companies, no, very less company are using the Hortonworks because it's much expensive as compared to the Cloudera. So most of the companies prefer the Cloudera distributor uh, in the real time for the production purpose, and for the development also Cloudera they are preferring there. So we will talk about the Cloudera by today. We will go ahead with Cloudera distribution right now. So now coming to the key features. Key features means some of the, like every framework or every tools has some of the key features. As you are aware of Java, if Java came into picture, so it has some features as compared to the C++. So like that, Hadoop has some features here. So Hadoop, as we know, is meant for large data sets only. Exactly, because if we have a huge volume of data where we cannot able to store that data into our traditional system, that's why Hadoop came into picture. It's meant for large data sets only, first point. Second is it is a OLAP data. OLAP data or OLAP system we can see. OLAP system. What does it mean? As we know, data warehouse is also a OLAP system. Why? Because where we are storing the historical data. Here also we are storing the historical data only. Historical data. Because if we talk about analyze data, if we talk about analyze tools, or analyze like that, so it means they have the old data, they have the historical data. That's why they can able to analyze it and they can take the decisions. Okay, not the day-to-day data, because if I have yesterday data and I want to analyze, like some of the problem statement is there, so it is not possible, because you have to take at least 1 month of data and then go ahead with predictions. So it will work there. Now coming to third point, Hadoop is meant for batch processing and not for real-time processing. Exactly. Batch processing, what is this batch processing here? So batch processing means after getting the data, like I'm getting the data from one of the RDBMS tools, one of the RDBMS tools. So before processing, we have to get whole data into our HDFS, that's the Hadoop distributed file system, then go ahead with processing. So that is known as batch processing. Okay. So take an example, like if you go to bank, uh, not the online processing I'm saying, if you go to initially before coming to the online on net banking, you go to bank for deposit purpose. Okay, so what happened, you have to just fill the form and give that form to the one of the clerk of USM, and you submit your money with that form and you come back to home. So at least it will take 1 day to get the message of confirmation to you. Okay, so it means what? They are collecting whole things first, and then they are going to process your money to deposit it. Let's deposit the your main purpose. So that is the batch process. Nowadays, what happen if you go at net banking and you go ahead? So take an example like ATM. If you go ahead ATM and you withdraw money there, you withdraw money there. So what happened within a seconds only? Within a seconds, you get a message, you have deposited this, you have credited with this money, and your available is like that. So it is a real time processing. So at the same time, everything is updated the system. So it's a kind of real time system, but Hadoop is not meant for real time system. It is meant for batch processing. So we'll talk. Okay, so it's a big big drawback of Hadoop. So also in the Hadoop ecosystem, there is a one of the components we'll discuss about later, the for the real time processing, and it will be very useful components. We'll discuss about that later. So now coming to the fourth point, Hadoop is made for write once and read many architecture. It is immutable file system. Exactly. So as HDFS, if you're talking about the Hadoop distributed file system, so it's a write once and read many. After writing the data onto the HDFS, we cannot able to what edit the data, or we cannot modify the data. It's the SDFS are we can say features. Okay, so we'll talk about this. We'll see the architecture for this. Okay, one of the architecture is there, or we'll see on that architecture why it is like that, and it is immutable. Immutable means can't modify. Okay, immutable files of system. It means if I write once and we cannot go ahead modify that data, that is not immutable. Okay, so now coming to Hadoop use commodity hardware. So nowadays in our own laptop, like whatever the laptop we are using, and in that laptop there is a hardware that is also commodity hardware, that is not enterprise hardware. Why? Because it's very inexpensive. Laptop price, whatever the laptop price you are getting, like 30,000, 30K up to 50K, we are getting a good configuration laptop, right? But if you go ahead with, and we are getting around 1 TB of hardware, around 1 TB of hardware right now in the configuration of this laptop. So what do you think? What it's the kind of enterprise hardware? No, it's also commodity hardware we are using in our laptop. Because if we talk about enterprise hardware, it's very expensive, and commodity hardware is very cheap. Cheap means it's very less expensive, and it's a very we can say cheap hardware, so commodity hardware. So we'll talk about these things in the Hadoop cluster. We are using the commodity hardware, but why we are using commodity hardware? We will talk in one of the diagram is there. So we will talk this commodity hardware and what is the architecture for these write ones and read many. There is a separate diagram for this. I will talk about this later. And now coming to the Hadoop is easily scalable. Scalable. Scalable means we can easily extend the cluster. We can easily short or delete the one of the node from the cluster. So it's the scalability. So what is the process for that? How we can say it's a very easily scalable. So you'll see about this into the diagram only. Okay. So now coming to what we are going to discuss in the this training sessions, like what we are going to learn here. So one of the tools known as Apache, sorry, ETL. ETL stands for extract, transform, and load components. So what is that? So as we have discussed earlier, instead of MapReduce, we are worrying about the ETLs only. So what we will teach here, Apache Pig. One of the ETL tool is Apache Pig. So that is a data flow script or transformation language. Transformation language. So we'll see what is that Apache Pig and all these things. And second is Hive versus Impala. If we use a Hive, if we are using Impala, both is same, but there's a little difference is there. So we'll see in that in Hive we are dealing with the table. We are dealing with a structured kind of data. It is meant for processing only. It is the processing tools. So we'll talk these things as well. And what's the scoop? Okay, Scoop is one of the tools for importing and exporting the data from different source system. Different means RDBMS. It supports only RDBMS to HDFS and HDFS to RDBMS. That's it. Talking about HBase, it is one of the Hadoop database system, and we are using the storing the data for this. So why it HBase came, and what is the advantages for this? So we'll talk about these things as well. And Apache Uzi, one of the ETL tool, is there, that is known as scheduling of the jobs. Okay, that is known as scheduling of the job. So now coming to Kafka. Kafka is one of the components in Hadoop which is important, as we can say, for a streaming kind of data. If we are getting the streaming data, like data is in motion, not a static data, not a position in one of the hard disk there. It is in motion. Take an example like Twitter's data. Twitter's data, if someone posted, and every second we are getting one comments like that or something, comments on that post. So that is known as motion data. How we can analyze that motion data? We'll see that as well with the help of using Kafka. So we'll go ahead with overview of these things, because you should have to focus on this Spark with Scala or Python. I will use here Python or Scala. So what were the convenient at that time? So we'll go ahead with these things. So I prefer the Python, but Scala is also good. So we'll see these things. That is the main topic in the Spark with Python. So Spark, what is Spark? So as we have told, it deals with the real-time processing as well as batch processing. So that is the tools which in the Hadoop ecosystem which are dealing with the real-time system. So this is all about the ETL tools which we are going to discuss in our training batch in this
One question,
session. Yeah. So now coming back, okay. So Hadoop is a master slave architecture. So master slave architecture, not a client server architecture. So let me explain about these things. First, I am going ahead. What is client server architecture? So after it, we'll go ahead master slave architecture. So what is client server architecture? So take the same example, Amazon.com. We are the client. We are using his services like Amazon.com services. So we are the client, and I am buying something from that Amazon.com. I just want to buy something, and I give some patterns and search the data. So the data is centralized because there is a single server in the back end. All the requests hit to that server only. Like if I'm saying thousands of the clients trigger send patterns at the same time or request at the same time. So that thousand requests keep the same server only. There is a single server. There is a single server, but where the data is centralized. Sorry, where the data is centralized. So what happened? So here the data is centralized into a single server, and they are getting the as per the request, and we are getting the data on the front page in front of me. So it's the client server. I am a client. I am hitting a server, single server. It is known as client server architecture. Here the data is centralized. Here the data is client server architecture. Client server architecture. Data is centralized. Centralized means the data is into a single server, we can say. In a single server, the data is centralized. But if you talk about Hadoop master server architecture, it is not a centralized, data is not centralized. What we are using here, distributed. HDFS means Hadoop distributed, means the data is distributed across the cluster, not the data is into a single uh, node or single server. So we'll talk these things, slave architecture. So we'll talk in briefly in the next sessions. Okay. So it's a kind of so you have understand the data client server architecture. It's a data is centralized into single server and processing also centralized here. Okay. So how the process is centralized here? So we'll talk these things later with the help of a diagram. So you will be a better idea about this centralized client server architecture and master server architecture. So before coming to this, so we have to install something to work on the Hadoop. That is the prerequisites you can say. First is Linux OS. Any OS you can prefer. It should be Ubuntu, it is Red Hat, any OS you have. It should be Stand OS is also fine. So no problem. Second thing is Java, because Hadoop is fully developed on Java and you have to deal the processing as you know MapReduce is the core processing tools. So it's also right in the Java. So that's why we need Java version here. So at least 1.6 there's a minimum and one later version. So we can say Java 6 or later. Later means you can either use Java 7, Java 8, Java 9 like that. Now coming to on the top of this, you have to install the Hadoop. If you install the Hadoop, you will get these two components by default because it is a core components. By default, you will get these two components. One is the SDFS for the storage wise, and second one is MapReduce for the processing wise. So this is two components you will get by default. Rest of the tools we have discussed in here, ETL tools, that is not embedded in Hadoop. You have to exclusively install this system. So no worry about these things for the installation and all these things. So this is a prerequisite why we are saying if someone asks what is the prerequisite to work on the Hadoop, you have to tell like this. First there is a Linux system. Second the Java should be here. Third one is you have to install the Hadoop, and then you can start the work as per the components you need. So this is the prerequisites. But here you don't worry about the prerequisites of this thing. I will share the link with you. You have to install that things, and there you can get everything, all the tools for the Hadoop, all the ETL tools is there, everything is there, so no need to worry about installation things. So that is fine. Now coming to Hadoop, okay, Hadoop development, because what we are going to teach is the Hadoop developer role. So as a Hadoop developer, there are two types of developer in Hadoop. One is the MapReduce developer. You have, if you are good in core Java, you can go as MapReduce developer. But if you are good in SQL or structured query language or some Linux command, if you have, so you can go ahead with ETL developer. Okay, so ETL means, as I have already told you, extract, transform, load. So it's ETL developer. For the ETL developer, you are the responsible for these tools. Big Hive Impala. It's not a very, it's not a very tough way. I'm saying it's very easy if you spend time around 1 or 2 hours every day on these tools. Okay, so you will be very, you will learn more and more, and it's very easy for you. So there's the ETL developer as this. So let me start.